Gaussian elimination with partial pivoting is commonly used when the elements in a column are not multiples. Check the procedure here in numerical solutions to see problems. Gaussian elimination is one approach in solving systems of linear equations. This method uses half of the solution by creating a triangular matrix, then computing for the values by algebra. In transforming a matrix, extract the coefficient of each term and arrange them in an augmented matrix. The other Gaussian elimination variation is with partial pivoting. This method looks for a pivot element used to zero out other elements in the column. The pivot element will be equal to 1 to easily eliminate others in the column. The other significant feature of partial pivoting is the interchanging of rows. The problem is the second example used in Gaussian elimination without pivoting. To verify that the procedure will still provide the same accuracy of answers, even with different approaches. There are 4 equations for 4 unknowns. After creating an augmented matrix, scout over the coefficients of x and determine the most dominant value. In this case, it is 3, found on the third row. So we place R3 to the top of the matrix. Before eliminating elements, the pivot element should be equal to 1, which would entail that we divide the first row by 3. By doing that, we have the first element now as 3 over 3, or 1. Next is 2 over 3, or 0.6667. The third element also becomes 1/3, and the fourth is negative 1/3. The element under the constant becomes 5/3, or 1.6667. Having a pivot element of 1, it would be easier to zero out all the other elements in the column. Starting with the second row, we use R2 less twice of R1, where the first element is 2 less twice of 1, giving 0. The second element is negative 1 minus twice of 0.6667, which becomes negative 2.3334. This is followed by 3 less twice of 1/3, giving 2.3334. The fourth element has 2 minus 2 of negative 1/3, which becomes 2 2/3. From the constant column, 20 less twice of 1.6667 gives 16 2/3. Do the same elimination process to the third row. This time, the operation is the difference of rows 3 and 1. The first element from row 3 then becomes 1 less 1, which is 0. Then 1 minus 2/3 is 1/3, or 0.3333. The third element has 1 minus 1/3, giving 2/3. For the fourth element, there is 1 minus negative 0.3333, making 1 1/3. From the constant, we have 10 minus 1 2/3, giving 8 1/3. From the fourth row, we zero out the first element by using the operation R4 minus R1, where this starts with 1 minus 1, giving 0. The next is 4 minus 2/3, which becomes 3 1/3, followed by negative 2 less 1/3, resulting to negative 2 1/3. The fourth element has 1 minus negative 1/3, which is 1 1/3. And from the constant, there is 0 minus 1 2/3, yielding negative 1 2/3. After completing the transformation of the first column, we move to the second and start with the determination of the pivot element. The choices for the second column are -2 and 1/3, a third, and 3 and 1/3. We are to choose the most dominant element, which is 3 and 1/3, from row 4. So interchange rows 2 and 4 to place the element up the column. Next is to make the pivot element equal to 1. So we divide row 2 by 3 and 1/3. This transforms the whole row 2 from the start having 0 over 3 and 1/3, giving 0. The second element is 3 and 1/3 divided by 3 and 1/3, which makes 1. The third element is -2 and 1/3 divided by 3.3333, which is -0.7, followed by 1 and 1/3 divided by 3 and 1/3, which makes 0.4. Then the last is -1 and 2/3 divided by 3 and 1/3, which is -0.5. After preparing the pivot row, we can zero out the other elements in the second column. Starting with the third, we use R3 less a third of R2, thereby having 0 plus a third of 0, which is equal to 0 for the first element. This is followed by a third less a third of 1, which gives 0. Then 2/3 minus a third of -0.7, which is now 0.9. There is also 1 and a third minus a third of 0.4, becoming 1.2. And lastly, 8 and a third less a third of -0.5 then becomes 8.5. For the fourth row, the operation is R4 plus 2 and a third of R2, starting with 0 plus 2 and a third of 0, which is still 0. Next is -2 and 1/3 plus 2 and 1/3 times 1, which is also 0. The third element is 2 and 1/3 plus 2 and 1/3 of -0.7, leaving positive 0.7. Then 2 and 2/3 plus 2 and a third of 0.4 becomes 3.6. From the constant column, 16 and 2/3 plus 2 and a third by -0.5 is 15.5. This completes the second column. Moving on to the third column, where we start by choosing a pivot element again. The choices are 0.9 from the third row and 0.7 from the fourth. The pivot element is the more dominant element, which is 0.9. So the arrangement of rows will remain the same. We are to make this pivot element equal to 1, so divide the whole row by 0.9. The initial element is then 0 divided by 0.9, giving 0. The next is also 0. The third element is 0.9 divided by 0.9, giving 1, followed by 1.2 divided by 0.9, resulting to 1 and a third. Then 8.5 divided by 0.9 is 9 and 4/9, or 9.4444. To finally have a triangular matrix, we have to zero out the last element from the third column, and this is through R4 minus 0.7 of R3. The first element then is 0 less 0.7 of 0, which gives 0. This is also true for the succeeding element. The third element has 0.7 less 0.7 of 1, which is now 0. Then 3.6 less 0.7 of 1 and 1/3 gives 2 and 2/3. Then the last element has 15.5 minus 7 of 9 and 4/9, resulting to 8.8889 rounded off. With the completion of the matrix, we employ algebra to solve for the variables x, y, z, and w. Starting from the bottom, we take 2 and 2/3 of W as 8.8889, where W is 3 and 1/3. The third row also has the equation Z plus 1 and a third of W as equal to 9.4444. Replace W by 3 and a third and isolate Z to have 9.4444 less 1 and a third of 3.3333. Z is then simplified as 5. From the second row, the equation generated is Y less 0.7 of Z plus 0.4 of W as equated to negative 0.5. Plug values of W and Z as 3 and 1/3 and 5. Then transpose the other terms with the constant to have Y as negative 0.5 plus 0.7 of 5 less 0.4 of 3 and a third. Y is then simplified as 1 and 2/3. From the top row, the equation is X plus 2/3 of Y plus a third of Z less a third of W as equated to 1 and 2/3. Just the same, place solved values of W as 3.3333, Z of 5, Y of 1.6667 into the equation. Then isolate X, where after simplification, X is solved as 0.